So hello all data science learners. Today we are again with another video on the topic of regression modeling. So regression is basically different from classification. In classification basically we have different classes, 1 2 3 or n number of classes are there, which we need to classify from basis of our data set. But in regression we will be predicting some continuous values for it. Suppose that the age of we can predict age of someone on the basis of its height, again some features from it. So let's move to the VS Code. So, what is regression? Regression is a statistical approach used to analyze the relationship between a dependent variable and one or more independent variable. So, basically, dependent variable is the target variable which we need to predict, and the independent variable is the variables from which we will be predicting the output. So regression and regression modeling, we have many types of regression, linear regression, multiple regression, polynomial regression, and stepwise regression. In this video we will be covering linear regression and stepwise regression. So basically in regression in linear regression we can say we generally we try to create a best fit line so that our predicted output will lie on the that best fit line, and the data which from which we are predicting the output, that is independent variables are present on that graph, and using that variables we will be predicting outputs which will present on the best fit line. In further video, in this video we will be seeing the how to construct best fit line and many more things. We will also visualize it. So let's start with importing the libraries, matplotlib, pandas, and numpy. Then we are using a height weight dataset, basic dataset. In this height weight dataset we are having the weight and height. Suppose we are giving a weight and we will be predicting height for it. So using scatter plot you can see that this is the weight and this is the height. So this data is spread in this graph. So we will be creating a best fit line. Suppose this is the line. Suppose we create a line here. So the outputs, suppose we input is weight and we need to predict the height. So the output of height will lie on the best fit line. We will create it in this video only. So let's continue to it. So we will be dividing the independent and dependent feature. X will be our independent feature and Y will be dependent feature, that is height. So in this we will be predicting height on the basis of weight. So again train test split, and as we do in all videos, Y train, this is the Y train data and this is the Y test. So now let's standardize this. So in regression we basically normalize and standardize the data so that a particular data cannot impact the whole data set, whole output of the model. So for it we are using sklearn pre-processing and using a function named standard scaler. So creating standard scaler, and then extend, we will replace this extend with this standard extend, and also same for the Y test. Let's plot this extend now. So this is standardized now. So the whole data is in the 1.5 between 1.5 to minus 1.5 to 1.5. So this standardized, not on a large scale, it will deflect our model. So we have standardized it. Now let's import linear regression class from sklearn.linear model, creating a model regressor. Then we will fit our extend and Y trend. So now here the regression has two main sub parts. That for a line mx plus c, we are having a slope and a intercept. So regression basically calculates the best regression for our best fit line and coefficient, that is slope for it. So here we are printing the slope and intercept. So this is the coefficient, that is slope, and this is the intercept for our line. So now let's plot using this coefficient and intercept, so you can visualize it nicely. So now this is the best fit line for our model we have trained. So suppose that this is the x, this is the x, it is means this is the weight of the person. Then we need to predict the height of the person. So the nearest point for the best fit on the best fit line is this. So 140 will be the height of the predicted output. This was the trend data, but suppose for new test data, this is the point of suppose we are taking 0.5 between minus 0.5 to 0, we are taking a weight, standard weight. So for this point is the nearest point. So the height of the height predicted will be 150. So here we will be having output will be different numerical continuous values. So now let's predict the test using test data. Let's move to performance metrics. Previously we have seen evaluation of models. So in regression we use mean absolute error, mean squared error, and absolute error. So let's print all of them. So here the mean squared error is 109, quite high. Then mean absolute error is 9, and root square mean is 10. So using this evaluation we can compare different models. Now let's move to stepwise regression. So stepwise regression is generally used when there are a lot number of features. Suppose there are 100 numbers of features for predicting a single output. So here it is seen that some of the features are important, but some of the features are not important. Suppose two features are there, but they are interrelated. So if one feature is removed from it, then it will not affect our model. So we use stepwise regression to find out the features which are important for our regression, so that we did not calculate it further and it will not waste our time. So we are using IS dataset here, and logistic regression is our model here. Then selector, we are using sequential feature selector from sklearn for this. So in this we are putting the n features equal to select equal to 2. So we are basically selecting from this iris dataset 2 features which are important, and for the model of logistic regression. So let's feed this scale selector on this x and y. Then we will be selected features will be stored in selected features. So let's print the selected features column for the selected features. Let's run it. So the selected features are petal length and petal width. So the main important parameter in this iris dataset which will be used for predicting the output is petal length and petal width. So this was all for the regression. So basically in regression we try to create a best fit line to predict the output, and all the outputs are present on the best fit line itself. So thank you and have a nice day.